Let's have some fun with circles. So, circles and stars in particular. So, using your compass is really easy to make a very nice circle. And we can do some nice experiments on circles. Take, for example, 5. If we were to roughly spread out 5 points in a circle, and then connect them. Well, one way to connect them is to make a pentagon. That's connecting every point in order. What if we skipped a point? And notice that if I skip a point going clockwise, it's the same as skipping 2 going counterclockwise. And this is going to result in a star. And it's the only 5-pointed star. It's the classic one that your teachers probably put on your homework or exams. Let's try another circle. What else can we do? What if I took a number like 8, for example? So 8 dots are pretty easy to spread around the circle. So here are 8 dots around the circle. Now if I were to start with one of them, I have the option of I can skip every one. What does that look like? Well, it's connecting every other dot. Well, if you take 8 things and connect every other one, you'll connect 4. That's because 2 goes into 8 4 times. And this ends up being a square if the dots were perfectly aligned. And you could go and connect the remaining dots the same way, and you would get a pair of squares. Sounds quite nice. And a pair of squares makes an 8-point star. That's rather nice. What about another circle? I'll make a smaller one here, try to fit it on the paper. And what if I spaced out 8 points again? 8 points spaced out on a circle. This last time I connected every second point, and I went counterclockwise that time. This time let's start with a point and connect every third going counterclockwise. Every third counterclockwise. Let's see what happens. So 1, 2, 3. Now 3 does not go into 8 evenly. 1, 2, 3. So let's see if we get something different. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then there's one more to connect. And that we get this is another 8-point star. This is rather nice, isn't it? So what's left with 8? Well, we could make another small circle up here. Whoops. And try connecting every fourth. What would happen if we did every fourth? You may want to think ahead of time. What would happen if I connected every fourth point? Well, if I'm starting here, doing every fourth counterclockwise, what does that look like? 1, 2, 3, 4. I go directly across the circle. 1, 2, 3, 4. I'm back to where I started. Well, that's kind of a boring star. It actually amounts to just connecting points on the opposite side of the circle. Antipodal points, we would call them, mathematical parlance. So that's an 8-point star, but not a very interesting one. So with the number 8, we have two stars. One of them's connecting every second point, one connecting every third point. Couldn't do any more than that. So bigger numbers are better. Let's pick another number. Let's get a bigger circle here. And let's try 15. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 points that are somewhat distributed evenly, not precisely. And let's try some colors. Let's green. Green will be every second counterclockwise. And we'll do a couple on here. So what is that going to give us? Well, 2 doesn't go into 15 evenly, so we know this isn't going to close up into a square or a triangle or any such thing. Because as we go around here connecting every second vertex, we're not going to quite make it back to where we started. Look, we're a little short. 1, 2. And so we're going to get a star. The points aren't going to be very pointy, but it will be something kind of interesting, kind of pretty. Or whether you find it pretty or not, of course, depends on your own aesthetic. What kind of 15-point star do you like? Going around twice works. So there's our 15-pointed star. Let's do another color. So we'll let red be every third counterclockwise. What does this look like? So it's going to be a little pointier. These are pretty fun experiments. And there are lots of these in math. No, I messed up something here. No, third is fine. Yeah. But this makes sense, doesn't it? Right, because 3 goes into 15 5 times. And so I went around and I have a pentagon. And so I could do that again. All right, so 3 goes into 15 5 times. So we get a 5-sided shape. We get a pentagon. And so the red star that I get here is going to be composed of how many pentagons? How many pentagons are we going to have? There's another one. So far my colors are kind of Christmassy. Mathematics makes for phenomenal Christmas decorations, I have to say. The top of my Christmas tree is no ordinary star. It's what is it? I can't remember the name of it actually off the top of my head. But I think it's a stellated dodecahedron. I'll have to show you guys next time. Alright, so there's that one. That's every third. Now, we could also do every fourth. We could do every fifth. That will yield triangles, a whole bunch of triangles, 5 of them actually. We could go every 6th and 7th. I can't do 8 because 8 will be the same as 7. So we could do 6, we could do 7. Let's choose 7 for our last example. So 1, 2, 3, 4, 5, 6, 7. This is going to be a very spiky. And maybe you'll start to build some conjectures. 1, 2, 3, 4, 5, 6, 7. What makes one star spiky and another one not? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You might be seeing a pattern with this star. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. and we're just going to kind of precess actually around the circle, 7 being what it is. We're going to get this phenomenal shape. It's this sort of stuff that might help you understand why anybody would major in mathematics. So there ought to be a, some sort of 15-sided shape in here, but there isn't because our points aren't equally distributed. But there's a very interesting kind of shape, isn't it? So I'll leave you with that. Have a good day.